All right, we made it. Number 52, the last question on our practice test for test rather, number 1. And number 52 tells us to graph the function, and we've been given a piecewise function, f of x equals 5 if x is greater than or equal to 1, and f of x equals negative 2 minus x if x is less than 1. So we're going to graph this piecewise function here, and to help us, I went ahead and made xy tables for each piece of our function. So here we have f of x equals 5, which is this first piece, and then we have f of x equals negative 2 minus x, that's the second piece here. And let's go ahead and fill in our x values for both of our tables here based on what our domain restrictions are for each piece. So here in our first piece, f of x equals 5, we are only interested in x values that are greater than or equal to positive 1. And so if our x values have to be bigger than or equal to positive 1, we're going to start our table at 1. And from there, we're going to go up, right? Because they have to be greater than. So 2, 3, 4, that looks fine. And how about for f of x equals minus 2 minus x? Well, we're only interested in x values that are less than 1. And because we're interested in values less than 1, what I'm going to do is I'm actually going to start my table at 1, but we have to make sure that we are taking note of the fact that the domain restriction says less than 1. So what this is going to end up being is an open circle on our graph. So I don't know what the corresponding y is yet. We haven't checked that yet. But because this domain restriction says x has to be less than 1, we can still evaluate what this part of the function is at 1. We just have to take note that when we plot this particular point, whatever the corresponding y is, that is not going to be a closed circle, but rather it's going to be an open circle. And I think that'll make a little more sense when we actually go ahead and graph. All right, so if we're starting at 1 and we want values less than that, well, let's see, 0 is less than that. How about negative 1 and negative 2? We won't choose anything too complicated here. All right, so let's go back and start evaluating. Let's start here on the left, f of x equals 5. Well, notice with this piece of our piecewise function, there's no variable here on the right where we can plug in any x value, right? It's simply a 5. We can't plug in 1 anywhere. We can't take 2 and plug it in anywhere, right? There's no x variable that we can plug into. It's always 5. So what that means is our work is relatively straightforward here for this piece, because no matter what the x value is, the corresponding y is always going to be 5. All right? So that makes our life a little easier. How about over here? Let's see what happens. Well, we have f of x equals minus 2 minus x. Now in this case, we do have a place, we do have an x variable that we can plug into, so we are going to have to do some evaluating here. So let's go ahead and see what the corresponding y is when x is 1. So we have f of 1 equals minus 2 minus x. All right, so we have minus 2, and we're going to distribute that negative through. So we have minus 2 minus 1, and of course, minus 2 minus 1 is negative 3. So our corresponding y when x is 1 is a negative 3. All right, fair enough. Let's go ahead and clear this away and start again. All right, so how about when x is 0? So when f of 0 is what we're trying to find, well, we're going to take that 0 and plug it in anywhere we see an x. So we have minus 2 minus 0. Well, that's negative 2, and again, we can distribute that negative through, so we get a minus 0. Well, minus 0 plus 0, that's not adding or taking away any value, so that really just goes away, and we're left with a negative 2. So when x is 0, the corresponding y is minus 2. All right, we're on a roll here. We'll keep going. And now we want to evaluate when x is negative 1. All right, so we have negative 2 minus negative 1. Well, that comes down as negative 2. We'll distribute that negative through, and a negative times a negative is a positive, Negative 2 plus 1 is negative 1. So when x is negative 1, the corresponding y value is negative 1. And lastly here, we will find what the corresponding y is when x is negative 2. So we have negative 2 minus x, or in this case, since our x is negative 2, we'll plug that in. So we have negative 2, we're going to distribute that minus through. A negative times a negative is a positive. And so negative 2 plus 2 gives us a 0. So when x is negative 2, the corresponding y is 0. And now all of these are just ordered pairs, aren't they? So let's go ahead and plot them. So let's plot 1, 5. And let's take note that because in this case the x value was 1, and in this piece of the piecewise function x had to be greater than or equal to 1, we know that this is going to be a closed circle, don't we? So when we plot 1, 5, so 1, 5 up here, we'll plot it with a closed circle, and then 2, 5, and then 3, 5, and 4, 5, and that trend will continue. So we end up with a constant here, a straight horizontal line that starts at x equals 1 and goes to the right. All right, and again, this is a closed circle. This point here at 1, 5 is a closed circle because our inequality here was less than, greater than, or equal to. So, or equal to means we're going to go ahead and close that circle in. All right, let's graph 1, negative 3, keeping in mind that this is an open circle because our inequality was simply x is less than 1. All right, so 1, negative 3, we'll graph it, but it'll be an open circle. 0, negative 2, go ahead and graph. Negative 1, negative 1, be right here. And negative 2, 0, right there. And so we'll go ahead and continue that line through. All right, so there is our piecewise function number 52. Again, I think it's easier to make XY tables for each piece of your piecewise function. Go ahead and gather your x's based on what your domain restrictions are, being careful to note any inequalities that will make your circles, your points open or closed depending on what those inequalities are. Plug in your x values, evaluate just like we've been doing for several math courses now, and graph those points, and you should have your graph relatively come together nicely. All right, so there's number 52, the end of chapter or test practice number 1. It was a lot of fun. I hope you guys found it enjoyable. I'm going to have a wrap-up video after this, excuse me, with just some tips and tricks on how you can be successful on your upcoming test. So if you enjoyed the video series, please let us know. Give us a like. If there's anything you want to see that you didn't see, or maybe the quality wasn't what you were expecting, by all means, I always welcome feedback, so please let me know. All right, I will see you guys around campus. This is Joe Brownlee with Palm Beach State College. Thanks for watching.